TON 618 carries a mass so enormous that it outweighs more than 36 billion suns. A figure so far beyond imagination that even astronomers struggle to give it meaning. It has existed for more than 10 billion years. Surviving collisions, consuming stars, and bending the fabric of space until light itself gives up. Yet, for all its power, the universe quietly reminds us of a truth older than any galaxy. Nothing lasts forever. Not stars, not galaxies, and not even an ultramassive black hole that has ruled its corner of the cosmos since the dawn of time. So the question that rises from the silence of deep space is both forbidden and irresistible. What could possibly be large enough, powerful enough, or patient enough to bring the life of TON 618 to an end? When scientists attempt to describe the death of a black hole, they always return to the same three possibilities. The only three endings the laws of physics currently allow. The first is starvation. A black hole without fuel slowly fades into a silent shadow as the surrounding galaxy runs out of stars, gas and dust. Its accretion disk cools. Its jets disappear. And the monster that once lit up the cosmos becomes a dark relic drifting in an empty sky. The second path is evaporation through what physicists call Hawking radiation. A faint leakage of energy that slips out from the edges of space-time. This process unfolds so slowly that the concept of time itself begins to lose meaning. Even a small black hole would take longer than the age of the universe to vanish. And an ultra-massive giant like TON 618 would require a timescale beyond anything human language can measure. The final ending is collision. The catastrophic dance of two black holes spiraling inward until gravity tears their horizons apart and merges them into a single, larger being. It is the closest thing the universe has to a death by fire. Yet TON 618 stands apart from all three. Its size, its age, and its extraordinary quasar luminosity mean it refuses to follow the script. Which leads to the question that sets the stage for what comes next. If every ending begins with hunger, then when will TON 618 finally stop feeding? To understand when TON 618 will stop feeding, we first have to understand why it shines so fiercely today. Its quasar blazes with a combined brightness of nearly 70,000 galaxies. A level of luminosity that only appears when a black hole is devouring matter at an extraordinary rate. Every stream of gas pulled toward its center is crushed, heated and spun into a glowing storm that radiates across billions of light years. But this brilliance is not permanent. The engine behind a quasar depends entirely on the galaxy that surrounds it. When that galaxy begins to run out of cold gas, the fuel that keeps the accretion disk alive fades away. The spiral currents slow, the heat subsides, and the monstrous glow that marks the presence of TON 618 begins to flicker. According to models of galactic evolution, even giants like TON 618 eventually exhaust the reservoirs that feed them. Astrophysicists estimate that its quasar could enter a silent phase in roughly 100 million years. A moment when the colossal beacon finally dims and the black hole sinks into darkness. Yet a fading quasar is not a dying black hole. It is only a change in the way it reveals itself to the universe. And that leads to the next question. If darkness returns, but death does not, then what truly happens to TON 618 after the light goes out? The idea that a black hole can slowly evaporate sounds impossible at first. Yet, it comes from one of the most influential insights in modern physics. Stephen Hawking discovered that the edges of a black hole are not entirely silent. Tiny fluctuations in the quantum fabric of space create pairs of particles. And when one falls inward while the other escapes, the black hole loses an infinitesimal amount of energy. This faint leakage is known as Hawking radiation. For a small black hole, the effect is dramatic over long cosmic stretches. It will slowly shrink, lose mass, and eventually evaporate in a final flash. But Ton 618 is not small. It carries a mass so enormous that the timescale of its evaporation becomes nearly unthinkable. To fully dissolve through Hawking radiation, Ton 618 would need a lifespan roughly equal to 10 raised to the power of 100 years. A duration so incomprehensibly long that it dwarfs the current age of the universe by 100 orders of magnitude. In human terms, it is the difference between a heartbeat and eternity. So if Hawking radiation cannot end Ton 618 within the lifetime of the cosmos, then what force could ever hope to finish the job? If there is one force in the universe capable of ending an ultramassive black hole, it is not radiation or hunger. It is collision. When two giants of comparable mass drift close enough for gravity to seize them, their orbits decay. Their paths twist into a tightening spiral, and they fall toward each other in a catastrophic embrace. The impact does not shatter them. Instead, gravity fuses their horizons, combining both masses into a single, even larger black hole. For most of the universe, this kind of merger is rare. But for a monster like Ton 618, it is almost unthinkable. Only a handful of candidates are large enough to challenge it. Phoenix A. The central black hole of the Phoenix cluster carries a mass so extreme it stands among the very few capable of rivaling Ton 618. Others may exist in the dense hearts of galaxy clusters, where hundreds of galaxies fall toward a shared gravitational center and their black holes grow fat on the chaos. Yet distance is the great shield that protects Ton 618. These titans lie billions of light years apart, drifting in regions of the cosmos that will never meet under normal cosmic expansion. So if no rival can reach Ton 618, then what scenario could ever bring two monsters of this scale into collision? For decades, cosmologists have asked whether the universe will expand forever or eventually slow, reverse, and collapse back into itself. This latter possibility is known as the Big Crunch, a scenario where gravity reclaims its dominance and the fabric of space begins to contract. If this reversal ever occurs, galaxies that are now drifting apart will instead accelerate toward one another. The larger the structures, the faster the fall. Clusters collide with clusters. Their central black holes spiral inward, and the universe enters an age of mergers unlike anything seen before. In such a collapsing cosmos, Ton 618 would no longer be isolated. The unimaginable distances that protect it today would shrink. Other ultramassive black holes, including titans like Phoenix A, would be drawn toward the same gravitational center. Their horizons would distort. Their accretion disks would tear apart. And eventually every one of them would plunge into a final, universe-scale collision. TON 618 would not die in this moment. It would be absorbed, its identity erased as it becomes part of a single ultimate black hole whose mass contains everything the universe once held. A true gravitational end state. So, if this is the fate that awaits in a collapsing universe, then what danger could possibly lie hidden inside TON 618 itself? There is a darker possibility scientists rarely discuss. Not because it is unlikely, but because its implications reach far beyond the fate of a single black hole. In theoretical physics, every black hole carries an entropy, a measure of how much information is stored within its horizon. For ultra-massive black holes, this entropy approaches levels so extreme that the quantum state of the horizon may no longer be stable. Some physicists propose that when a black hole becomes too large, it can cross an invisible threshold where its internal configuration collapses into a lower energy state. Such a transition would not be gentle. It could release a burst of vacuum energy, a fundamental form of energy embedded in the fabric of space-time itself. And in the most dramatic scenario, it might trigger the formation of a bubble of false vacuum, a tiny pocket of space governed by different physical laws. If such a bubble appeared, it would expand at nearly the speed of light, rewriting the universe as it passed and erasing everything in its path. In this view, the threat does not come from outside TON 618, but from within. The monster carries the seed of its own annihilation, and possibly the annihilation of everything else. So if TON 618 can destabilize the vacuum of space-time, then what would its final echo look like before the universe disappears behind it? For all the ways TON 618 might disappear, none of them resemble a traditional death. In modern theoretical physics, a black hole does not truly erase the matter it consumes. Instead, the information carried by that matter becomes encoded on the surface of its event horizon, woven into a two-dimensional imprint that expands as the black hole grows. This idea, known as the holographic principle, suggests that every star, every cloud of gas, and every fragment of cosmic debris swallowed by TON 618 still exists in a transformed state at the boundary of its gravitational world. If the black hole were ever to vanish, whether through evaporation, collapse, or absorption into a larger singularity, that stored information would not simply vanish with it. The final stages of a black hole are believed to release the entire record of its history back into the universe, a faint echo of everything it consumed across billions of years. In a sense, the end of TON 618 would be less a disappearance and more a transition, a shift in how its story is written into the structure of reality. So if TON 618's last act is to reveal every memory it has taken from the cosmos, then what meaning would such a revelation hold for humanity? TON 618 does not live the way a star lives. It does not burn. It does not age. It does not drift toward exhaustion. It exists in a state beyond the ordinary rhythms of cosmic time. A presence shaped only by gravity and the matter that dares to fall toward it. And because it does not age, it does not die in any familiar sense. Its end arrives only when the universe itself reaches its own final boundary, when space and time lose their meaning, and the cosmic stage on which TON 618 has stood for billions of years finally collapses. That ending might come as a whisper of Hawking radiation in the farthest future, or as the violent crush of a big crunch, or through a quiet and sudden rewriting of reality in a vacuum decay. No one knows which path the universe will take, but every path leads to the same truth. Ton 618 will endure until the cosmos draws its last breath, and until that moment arrives, it remains one of the greatest chapters ever written in the story of existence. A monument to the scale of creation and the mysteries that still wait in the dark. So, the only question left is the one the universe quietly returns to us. What do we choose to learn from a monster that outlives time itself?